susunod na programa ay rated PG. Ito ay nangangailangan ng patnubay at gabay ng magulang para sa mga batang manonood.
Mga kachika, nagbabalik na naman po kami ngayong linggo upang makipagkwentuhan sa inyo. At dahil marami pong nag-request ng part 2 ng ating episode last week, muli po nating inimbita ang mga gurong nagbigay ng maraming lessons and information sa atin noong nakaraang linggo.
Kaya wag na natin patagalin pa. Imbitahan na natin sila Miss Christine Naling, Mr. David Rumasanta, and Mr. Juan Miguel Lopez.
Excited ang ating mga viewers for today's episode, abay simulan na natin. At ang ating pag-uusapan ay tungkol sa chemistry of the environment. At tayo ay mag-focus sa soil chemistry. Gusto niyo yon?
Gusto ko yan, partner. Dahil marami tayong nararanasan na kalamidad. Maganda na matutunan at malaman natin ito para makatulong tayo sa ating environment. Let's start!
Magandang hapon sa ating mga kachika. Hayaan ninyong simulan ko ang ating sharing of knowledge for today. First, let us know what soil is. Yes, I know lupa siya literally, and it contains air, water, and minerals, as well as plants and animal matter, both living and dead. It is known that soil has its importance in different aspects, katulad sa production ng foods, sa maintaining the balance of carbon, ng nitrogen, and also sa phosphorus. That's why I'm going to tackle about the nature and composition of soil. The chemical nature of soil ay may mixture of weathered rocks and minerals, mga nabubulok na plants and animals, mga small living organism which includes plants, animals, and also bacteria. As I said earlier, soil consists of water and air. Ang productive soil ay merong solid fraction of almost 5% ng organic matter and 95% ng inorganic matter. Let's proceed now on distinctive layer of typical soil. A layer of a typical soil which is called horizon is the product of complex interactions between processes that develop during weathering. Yung horizon ay yung layer of soil or rock or set of strata with particular characteristics. Bacterial decay of residual plant biomass produce slightly acidic carbon dioxide, organic acids, and complexing compound that are carried by rainwater to lower horizons where they combine sa clay and other minerals, resulting to the change in the properties of mineral. Yung A horizon or yung pinaka-top layer of soil is several inches in thickness. Ang A horizon din yung tinatawag na topsoil. Ito rin yung soil layer na nagko-contain ng organic matter and also important siya sa productivity ng plants. There are other characteristics of soil which includes strength, workability, soil particle size, permeability, and extent of maturity. So, makikita nyo dito sa picture, it describes numerous soil that has a variety of horizons. Magsisimula tayo dito sa babang-baba, which is called the bedrock. Yung bedrock ay hard and solid rock beneath surface materials such as soil and gravel. Next naman is yung horizon sea or sea horizon. Ito naman yung weathered parent rock na tinatawag. Nagko-consist naman ito ng small pieces of rocks with cracks and crevices. B horizon or the subsoil. Yung kasunod ng sea horizon. Ito naman yung layer ng soil which accumulate organic matter, salts, and clay eluted from upper layer. Let us now move on sa E horizon. It is a mineral horizon kung tawagin sa upper part of soil. E stand for eluviated. That's why commonly called siya as layer of elution as of clay and aluminum. Ang A horizon naman is the topsoil. Nabanggit ko nga siya kanina. Rich siya sa decayed organic matter at sa ugat ng mga halaman. Last layer is the O horizon. It is the layer of horizon na may pinakamataas na percentage ng organic matter. Yan. Yung A horizon up to B horizon is matatawag siyang regolith. Sila yung layer of broken and unconsolidated rock. And yung mga halaman naman, that's what we call vegetation. For the production ng halos lahat ng halaman, water is basically important. Hindi lang basta water, but a large quantities of water are needed for production of most plant materials. That's why we need to discuss about water and air in soil. Kasama ang water sa three phase, which is the liquid making up soil. As you can see in the picture, the water in a plant evaporates into the atmosphere from the plant leaves. Ito yung tinatawag na transpiration, which is simply the release of water from plant leaves. I know that we are familiar to photosynthesis, which is giving oxygen, and its reverse process called respiration, releasing carbon dioxide. Yung mga soils na may mataas na organic matter ay mas nag-hold sila ng water than other soils. But it is somewhat less na available sa plants dahil sa physical and chemical sorption ng water sa organic matter. Ang water and clays have strong interaction kasi inaabsorb ng clay particles ang water on its surface. Ang large amount of water at ang clay ay pwedeng magsama, but once na nababad ang clay ng soil, ay nagkukos siya ng disruption, which is pagkasira ng soil structure. Kasi nakokonsume agad ng microorganism ang oxygen na nagdudulot ng degradation of water in soil. Yung required air for plants is hindi nila nakukuha kasi na-consume na agad. That's why many important crops maliban sa rice cannot grow on soil soaked in water.
Ngayong alam na natin yung nature and composition ng soil, ngayon, i-discuss naman natin yung inorganic and organic matter in soil. So first, let's have the inorganic components of soil. The formation of inorganic colloids from the inorganic soil components are produced from the weathering of parent rocks and minerals. So these colloids are repositories or storage of water and plant nutrients which can be made available to plants as needed. So inorganic soil colloids plays a role in the detoxification of substances that could harm plants because these colloids they absorb the toxic substances in the soil. So in determining soil productivity, the abundance or presence of these inorganic colloids are certainly an important aspect. So as we all know, the most common elements on the Earth's crust are oxygen, silicon, aluminum, iron, calcium, sodium, potassium, and magnesium. Therefore, minerals composed of these elements, particularly silicon and oxygen, constitute most of the mineral fraction of the soil. And the common soil mineral constituents are finely divided: quartz, orthoclase, albite, epidote, goethite, magnetite, calcium and magnesium carbonates, and the oxides of manganese and titanium. So now let's have the organic matter in soil. Organic matter mostly determines soil productivity, even though it typically constitutes only less than 5% of a productive soil. So there are three things that make the organic matter important in soil, and these are: so first is it is a source of food for microorganisms. Next is it undergoes ion exchange chemical reaction, and last is it contributes to the weathering of mineral matter, process in which the soil is formed. So the buildup of organic matter in soil is greatly influenced by temperature and by the availability of oxygen. Since the rate of biodegradation decreases with decreasing temperature, organic matter does not degrade rapidly in colder climates and tends to build up in soil. So in water and in waterlogged soils, decaying vegetation does not have easy access to oxygen and organic matter accumulates. So the organic content may reach 90% in areas where plants grow and decay in soil saturated with water. So here are the major classes of organic compounds in soil according to Manahan 2010. So first we have the humus. So the composition of humus are the degradation resistant residue from plant decay, largely carbon, hydrogen, and oxygen. And for the significance, it is the most abundant organic component. It improves soil physical properties, exchanges nutrients, and a reservoir of fixed nitrogen. Next is the fats, resins, and waxes. So for the composition, It is composed of lipids extractable by organic solvents. And for the significance, generally, only several percent of soil organic matter may adversely affect soil physical properties by repelling water, perhaps phytotoxic. Third is the saccharides. So it has cellulose, starches, hemicellulose, and gums for its composition. And for the significance, it is the major food source for soil microorganisms and it helps stabilize soil aggregates. Fourth is the nitrogen or N-containing organics. So for the composition, of course, it is nitrogen bound to humus. It has amino acids, amino sugars, and other compounds. For the significance, it provides nitrogen for soil fertility. Last is the phosphorus compounds. So it has phosphate esters, inositol, phosphates or the phytic acid, and phospholipids. And its significance is it is a source of plant phosphate. So now let's have the soil humus. Humus is composed of a base soluble fraction called humic acid and fulvic acids, an organic material that remains in the acidified solution, and an insoluble fraction called humin, or the residue left when bacteria and fungi biodegrade plant material. So humic substances has an influence in properties of soil even though it has a small percentage in soil composition. They have an acid-base character which serve as buffers in soil, and they significantly increase the water holding capacity of soil. Humic substances also strongly bind metals and serve to hold micronutrient metal ions in soil. And the aggregates of soil particles can also be stabilized by these substances and additionally can increase the sorption capacity of compounds by soil. So to clearly understand soil humus, let's watch this video.
Paano nabubuo ang humus sa lupa? Ang lupa na mayaman sa humus at sustansya o nutrients ay masasabi nating mataba o fertile. Kaya't mahalaga na malaman natin kung paano na ang humus ay mananatili sa lupa. Ang organic matter tulad ng mga namamatay na halaman, halimbawa nito ang mga ugat, dahon, bunga, at iba pa na nangamatay sa lupa ay kailangan upang ang mga mikrobyo o organisms ay mabubuhay sa pamamagitan ng pagkain sa mga ito. Sa pamamagitan ng mga organisms o mikrobyo, ang mga organic matter na nasa lupa ay unti-unting nabubulok o nadidecompose ng tuluyan hanggang ito ay maging humus. Ang humus na ito ang siyang kailangan upang ang mga nutrients o sustansya ay available sa lupa.
So next is the soil solution. The soil solution is the aqueous or aqueous portion of soil that contains dissolved matter from the chemical and biochemical processes in soil and from the exchange with the hydrosphere and biosphere. This medium transports chemical species to and from soil particles and provides contact between the solutes and the soil particles. It is also an important pathway for the exchange of plant nutrients between roots and solid soil aside from water, which is vital for plant growth. So for my last topic, we have the acid-base and ion exchange reactions in soils. So the mineral and organic portions of soils both exchange cations. Clay minerals undergo this process because of the presence of negatively charged sites on the minerals resulting from the substitution of an atom of lower oxidation number for one of higher number, like magnesium for aluminum. So cation exchange in soil is the mechanism by which potassium, calcium, magnesium, and essential trace level metals are made available to plants. When nutrient metal ions are taken up by plant roots, hydrogen ion is exchanged for the metal ions. This process, plus the leaching of calcium, magnesium, and other metal ions from the soil by water containing carbonic acid, tends to make the soil acidic. The buffering capacity of soil depends upon its type, wherein the soil acts as a buffer and resists changes in pH. So that's all, and before pala ako matapos, gusto ko lang i-shoutout yung mga tropa ko nung nung college sa Batangas State University. So, shoutout sa iyo Makoy, John Errol Rago, aka Pre, kay Boss Samuel Mismanos, kay Janiel Ray Salilid, and kay Dan Mirando. So, shoutout sa iyo mga pre. Stay safe and God bless. So, yun lamang po and thank you for listening to my discussion.
Dagdagan pa natin ang mga kaalaman ng ating mga kachika. So, today, I will teach you the adjustment of soil acidity. Most of the common plants ay karaniwang tumutubo sa lupa with a pH near neutrality. Kapag too acidic yung lupa, we can restore the productivity by liming or treating a soil to become less acidic. We can do this by adding calcium carbonate sa soil. Gaya nga po na makikita natin sa equation. Sa mga areas naman po with low rainfall, yung soil naman po is become too basic or alkaline soil. Because dahil nga din po ito sa presence ng mga basic salt. Yung alkaline soils naman po ay can be treated with aluminum or iron sulfate which releases acid during hydrolysis. Yan po, gaya po nung nakikita natin sa equation. Yung concentration of chemicals nga po sa soil are given in a mass unit. Yes, it can be parts per million, milligrams per kilogram, or micrograms per kilogram. Yung unit po na gagamitin natin ay nakadepende sa magnitude of the mass or chemical present per unit mass of soil. Usually, ang unit mass of soil po na ginagamit natin is kilogram. The movement of ionic nutrients such as nitrate, ammonia, phosphate is governed by ionic exchange reaction. An ionic exchange reaction is any of the class of chemical reaction between two substances that involves an exchange of one or more ionic components. So, an important characteristic of a soil is its exchange capacity. Yung exchange capacity nga po is essentially the extent to which a unit mass of soil can exchange a mass of a certain ion. Isa pa po, it is an important characteristic of soil in terms of its ability to leach ion. Another important process that occurs in soil is sorption. What is sorption? Ang sorption nga po is essentially the attachment of chemical to either the mineral or organic portions of soil particles and includes both adsorption and absorption. What's the differences between the two? Adsorption are the molecules adhere to the surface of the phase. Only sa surface na po. Ayan. Molecules are drawn into the bulk of the phase are called absorption naman po. Yan. Gaya po niyan. With low concentration nga po of pollutants, sorption can be described mathematically by a linear expression. Kd is equals to Cs over Cw. Cw is equals to the equilibrium concentration of the chemical in the water or mass per volume of water. Kd is a partition coefficient describing the sorption equilibrium of chemical distribution ratio. It's equals to mass per mass of soil or times mass per volume of water, which is the negative one. And Cs, lastly the Cs, the equilibrium of concentration of chemical on the soil. It is equals to mass per mass of soil. So, I think hanggang dito na lang muna ang i-share ko sa inyo. And I hope na may apply niyo yung mga itinuro namin sa inyo ngayong araw.
Siyempre naman po, sir. Pero, konting pahinga muna tayo, mga kachika. Uminom-inom muna kayo ng mga tubig. At sa aming pagbabalik, kami naman ni partner ang may ichichika sa inyo. Gusto nyo yon?
Siyempre naman partner, gusto nila yun. Kaya huwag kayong aalis, magbabalik kami. Dito sa Gen Cameroon!
Dude, 30 points, 14 rebounds, and 10 steals. MVP!
Yan nga ng Sunkist Ice si MVP.
What can you say dahil ikaw daw ang the man?
Truth is, I'm not the man. I just played hard for you. And especially you. Kasi, kahit ko yung matapik sa puwit na may pare, nice play. Trip ko rin yung mga chest bumps na may, yeah! Pero sa akin, yes!
Sunkist Ice Tea. Sarap, anis!
At ngayon, nagbabalik na kami. Hayaan niyong kami naman ni partner ang mag-share sa inyo. Let's go, partner!
Okay, so ang i-impart ko naman sa inyo for today is all about the macro and the micronutrients in soil. Let's first talk about the macronutrients in soil. These are the elements that occur in substantial levels in plant biomass and fluids. So these are called the macronutrients. In other way, these are the chemical elements or the substances that is essential in relatively large amount to the growth and health of a living organism. So the examples of it are carbon, hydrogen, and oxygen, which can be absorbed from the atmosphere, and also the nitrogen, phosphorus, and potassium, which is added to soil as fertilizers. And lastly are the calcium, magnesium, and sulfur, and etc. can be obtained from the soil. Let's give some more details about the examples of macronutrients in soil. First is the calcium. Calcium-deficient soils are relatively uncommon. When we say calcium-deficient soil, ito yung soil or yung lupa ay kulang sa calcium. So, in alkaline soils, the presence of high levels of sodium, magnesium, and potassium sometimes produces calcium deficiency because these ions compete with calcium for availability to plants. Application of lime is a process used to treat acid soils provides a more than adequate calcium supply for plants. So, nag-a-apply ng lime in order to provide calcium sa plants. Next is the sulfur. Sulfur is assimilated by plants as the sulfate ion or the SO4. Lack of sulfur in soil do not support plant growth well because sulfur is a component of some essential amino acids and the thiamine and biotin. So sulfur is one of the most important element in the macronutrients. Next is the nitrogen. Nitrogen is an important component of proteins and other constituents of living matter in its attachment to soil humus because it serves as a reservoir of nitrogen required by plants and it is essential in maintaining soil fertility. And it has two components, the inorganic nitrogen and the organic nitrogen. First is the organic nitrogen, which is it contains in soil is over 90%, which is usually the product of the biodegradation of dead plants and animals, while the inorganic nitrogen is from the fertilizers and the rainwater, which is often largely lost by leaching and has the additional advantage that its rate of decay then can release nitrogen to plants roughly parallels plant growth. So you can see in the figure 3 is the nitrogen sinks and the pathway in soils according to Manahan 2010. Also, the phosphorus. Phosphorus, like the nitrogen, it must be present in a simple inorganic form before it can be taken up by the plants. It can be applied as fertilizer leaches from the soil. Next is the potassium. Its high levels are utilized by growing plants. Potassium activates some enzymes and it is also essential for some carbohydrate transformations. Lack of potassium in soil can be generally reduce crop yields. Next, let's talk about the micronutrients in soil. Micronutrients are the chemical element or the substance that is essential in minute amounts to the growth and health of a living organism. So the examples of it are the iron and manganese, which occur in a number of soil minerals. Next is the sodium and chlorine, which occur naturally in soil and are transported as atmospheric particulate matter from marine sprays. And last are the boron, copper, molybdenum for nitrogen fixation, and the zinc, which can be found in primary or unweathered minerals that occur in soil. The fertilizers. It is a substance that is added to soil to help the growth of plants. We all know what is fertilizer. And the major components of crop fertilizers are nitrogen, phosphorus, and potassium. But magnesium, sulfate, and micronutrients may also be added. Sana ay marami kayong natutunan mula sa akin ngayong araw na ito. Ngayon naman ay pakinggan natin ang aking partner. Pasok, partner!
So, simulan na natin. Let's start with soil pollutants. So, first, we have pollutants from livestock production. Livestock is actually a process or practice in which you raise animals in agricultural settings. And these practice generates significant amount of environmental pollutants. Livestock manure has a very high biochemical oxygen demand, so it depletes oxygen rapidly when it gets to water wastes. The decomposition of animal wastes produces inorganic nitrogen that can contaminate the water and or actually with the potential nitrate or toxic nitrate. Meron din tayong tinatawag na inorganic nitrogen and phosphorus that is released to water that causes eutrophication or when the water is rich with a certain nutrient. In this case is inorganic nitrogen and phosphorus. Meron din tayong nitrous oxide that is released to the atmosphere from the livestock wastes, and this is an air pollutant as well. And lastly, we have methane generated in anaerobic degradation of livestock that is a potent greenhouse gas. The next one is pesticides and their residues in soil. So as we know, pesticides are widely applied in farming as they are very useful for the farmers for eradicating unwanted weeds and insects or pests. However, there are four major concerns regarding pesticides in soil that needs to be considered with respect to their licensing and their regulation. The first one is the carryover of pesticides and biologically active degradation products to crops grown in later seasons. The second one is biological effects on organisms in terrestrial and aquatic ecosystems, including bioaccumulation and transfer through food chains. So, meaning these pesticides could actually travel down or even up to the food chain. So, meron din possibility na we are affected by these pesticides. The third one is groundwater contamination, and the fourth one is effects on soil fertility. So, meron din tayong tinatawag na herbicides or those substances that is toxic to plants, and the farmers actually use this commonly to destroy unwanted vegetations. These herbicides are considered as the most common chemicals that affect soil and organism that it supports. These type of pesticides and the other foreign compound that remains in the soil for a very long time has its effect. One is that the substances become increasingly resistant to extraction and desorption process, meaning yung substances mahirap na siyang tanggalin after for a very long time that it has remained in the soil. Second one is that they become significantly less bioavailable to organism. And third, since yun nga, nagiging resistant na yung mga organism that it targets, their overall toxicity is decreased. So the bioavailability and extractability are usually associated with the interaction of the pollutant or the compound with the organic matter in soil. It is more pronounced kapag merong higher level ng organic matter in the soil. So the next one we are going to share is the wastes in soil. So the soil receives a lot of waste product from sulfur dioxide, from sulfur-containing fuels, nitrogen oxide from the atmosphere converted to nitrates, particulate lead emitted by the automobiles, and the heavy metals from the mines and smelters are all received by soil. So it is no surprise that soil is the receptor of many hazardous wastes. Various constituents of soils have different affinities or level of liking for organic contaminants. Take for example, natural organic matter. It has a very high affinity to organic contaminants and heavy metal ions. Many soil contain elemental carbon, such as black carbon, and these carbon are the material in the ash left over from the burning of the crop residues. So this material is probably the most important repository, or the place or the thing that stores the organic contaminants in the soil. So, isa pang problema is the volatile organic compounds, which is the gas emitted from certain solids and liquids. And nagiging problema to kasi it can contaminate the industrialized and commercialized areas, especially sa mga country na hindi ganun ka-strict yung pag-enforce ng regulations regarding this matter. The sources of the VOCs include underground storage tanks, yung leakage nun, landfills built before current stringent regulations were enforced, and improperly discarded solvents. So, as what have mentioned earlier, soil receives a large amount of pesticides as it is widely applied in farming. So, the degradation of the pesticides on soil highly determines their environmental effects. So, among the factors that needs to be considered are absorption of pesticide by soil, leaching of pesticides into water, effects of pesticides on microorganism and animal life in the soil, and lastly, possible production of relatively toxic degradation product. So the last part in soil pollutant is the soil loss and degradation. Soil is a very sensitive or fragile resource that could be lost by erosion and become so degraded that we cannot use it any longer. So physical properties of soil and its susceptibility to erosion are strongly affected by the cultivation processes or practices rather to which the soil is subjected. So for example, if you have this land area or you live in this area and you treat your environment or your soil with so much care and you plant more trees, more plants, it is less likely that you will experience soil erosion. However, when you disrespect your environment and just cut off trees after trees, for sure that will come back to you later on and you will experience such horrible soil erosions. So, we also encounter a problem called desertification, or wherein you observe a fertile land becomes so dry that it becomes desert-like. And this is associated with drought and loss of fertility. So other factors that is interrelated with desertifications are erosion, climate variation, water availability, loss of soil humus, and deterioration of soil chemical properties. So another problem aside the desertification is deforestation, which is the loss of trees. So kahit na sinasabi na this is less of a problem sa tropical regions because the forest there already includes existing species of animals and plants, but anyway, it's still a problem in our country. So yeah, anyway, deforestation also have devastating effects such as erosions, loss of nutrients of the soil, and worst case scenario is extinction of species of plants or animals. So the last one is soil erosion, or the loss of soil by the action of water and wind. And just so you know that water is the primary source of soil erosion. So, dahil tapos na tayo sa soil pollutants, we can now proceed to soil preservation and restoration. As we know, food is the most basic needs of humans. And where can we get those food? From plants and animals, which are both highly dependent to soil. So, indeed, preservation of soil and its ability to support plant life is the most basic part of food sustainability. However, we face problems that affect our precious soil, such as soil erosion. So, dahil doon, nagkaroon na tayo ng preservation of soil from erosion, which we call soil conservation. One example of practice that surely decreases the soil erosion is the conservation tillage, or in this case, no-till agriculture. This practice consists of planting a crop that is among the residue of last year's crop without plowing. And in the newly planted crop row, you kill weeds with herbicides prior to planting plants. The surface residue of plant material left on top of the soil can now help prevent soil erosion. So we have learned from many challenges that the nature have given us that trees are very effective for stopping soil erosions. So with that in mind, nagkaroon tayo ng agroforestry, or the promising alternative in sustainable agriculture, na nagpa-plant ka ng crops in between rows of trees to preserve and balance the soil, especially kung nagtatanim ka sa slope area. So for example, pwede ka ding pumili ng tree na capable of fixing nitrogen in this practice for the system to have an efficient amount of this nutrient. So sunod, meron tayong soil restoration. We know that soil can be impaired, pero soil actually have a degree of resilience, and once na matanggal na yung condition leading to degradation, it can recover. Pero in many times, more active measures called soil restoration are called for to restore soil productivity through the application of restoration ecology. So this may include physical alteration to provide terraces and relatively flat areas not subjected to soil erosion. Organic matter, on the other hand, can be restored through planting of crops, the residues of which are cultivated into the soil for partially decayed biomass, or the total amount of organism in a particular area. So remember that we must add nutrients and neutralize contaminants. Lastly, we have green chemistry and sustainable agriculture. Green chemistry is the field of chemistry and chemical engineering that focuses on eliminating or minimizing the use and generation of hazardous substances. This practice may significantly enhance agricultural productivity and sustainability, and it holds promise for preventing or alleviating problems such as that the non-target organisms have suffered, the resistance of weeds and pests from the agents that is used to eradicate them. Poorly trained and inadequately protected personnel in less developed countries have suffered from adverse effects of modern agricultural products and the problems caused by pesticides, herbicides, fertilizers, and lastly, disposal problems. Agriculture is a science of living organism applied to human needs for food and productions. So, in an attempt to find more sustainable and environment-friendly approaches to agriculture, it is wise for us to look to natural ecosystems that have evolved through the longest time. Such approach is actually based on biomimetics, or in which we attempt to mimic natural life systems. With that approach, we actually came up with biopesticides, which are the pesticides that came from natural sources. It is commonly most effective in integrated pest management program, and it has many advantages, such as It has a lower toxicity, has high specificity for target pests, effective even in very small amount, and it decomposes rapidly. It is actually more environment friendly than the synthetic pesticides. Gusto ko tapusin yung sharing namin ni partner. Gusto kong mag-share ng reflection sa inyo. I think it's really nice that we come up with alternatives and solutions for us to alleviate the problems that we are experiencing, especially the problems from nature. However, as we have experienced major natural disasters lately, it is truly time for us to reflect and acknowledge that the amount of disrespect that we have been giving our nature for decades or for even centuries has been starting to pay off. With that, I would like to end this sharing with 3 words. Let's do better.
Sa lahat ng sumubaybay at nanood hanggang dulo ng ating episode ngayong araw. Sana ay marami kayong natutunan at mai-apply natin ito sa pagtatanim natin ng halaman at ang mas maganda ay mai-share din natin sa iba.
Tama ka dyan, partner. At muli po, maraming salamat sa mga gurong sinamahan tayo sa araw na ito. At magkikita-kita po ulit tayo bukas dito sa Gen Kemerut. Keep safe, everyone!